Hello there, welcome to another episode of the Blockcrunch podcast, where we condense insights from some of the top investors, builders, and entrepreneurs in the crypto world into rapid-fire 20-minute conversations. I'm your host, Jason Choi. And this is also the first episode of a mini-series that I'm calling 500 Blockcrunch, because I'm incredibly excited to announce a partnership between the Blockcrunch podcast and 500 Startups, an early-stage venture fund that has invested in over 2,000 startups, including some you might have heard of before. This includes things such as Credit Karma, Twilio, and Grab, which is of course Southeast Asia's version of Uber, as well as some early-stage blockchain projects like Omise, Chain.com, and Lightyear, which is the commercial side of Stellar. And 500 Startups is not just one of the most active global investors, they're also incredibly hands-on and experienced when it comes to developing communities and helping entrepreneurs develop go-to-market strategies. That's why I'm particularly excited to partner with venture partner Bonnie Cheung, whom I've actually had on the show before, in creating content that we think could be the most educational to people in the space, regardless of whether you are a newcomer who's just trying to get a lay of the land, or if you are a seasoned investor or builder who wants to get a more macro view of some of the most pressing challenges as well as exciting opportunities in crypto today. But before we get started, I wanted to give a quick shout out to our friends over at Global Coin Research, who produce one of the most comprehensive newsletters every week covering all things crypto in Asia. And if there's one thing that I realized after coming back to Asia, it's the fact that a lot of exciting developments and teams here are not really covered by Western media. So if you want to stay abreast of the industry as well as stay ahead of the market, then Global Coin Research really is one of the best newsletters that you can subscribe to. And you can find them at globalcoinresearch.substack.com, or you can simply Google Joyce and Global Coin Research. And on that note, to kick off this series, in this first episode, we'll be covering the topic of scaling. So if you're a newcomer, hopefully by the end of these 30 minutes, you'll become more well-versed or at least interested in what scaling actually is and why it's such an important issue to so many people in crypto. And if you're a more experienced investor or a builder, hopefully this will give you a framework to think about layer 0 solutions to layer 2 solutions and beyond, and how they fit together to form the immense puzzle that is blockchain scaling. So without further ado, with me today to unpack the complicated topic that is blockchain scaling is 500 Startups venture partner Bonnie Cheung.
This is worldwide phenomenon.
Hey Bonnie, super excited to have you on the show and really stoked to work with you on this series. And I know we talked a lot about why we wanted to start this and the gaps that we see in the market today, but just for our listeners, could you explain why you wanted to start the series, especially since this is the first episode of the mini-series, as well as what you hope listeners can take away at the end of this?
Hey Jason, it's great to be back here. Having invested in over 2,000 startups over the years, never have we experienced a sector where we have this kind of explosion in terms of ideas, projects, and most important, the number of talents pouring into the space. But as time goes on, the amount of new projects started to go up exponentially, and it just became really hard, honestly, for me as an investor to get a full grasp of all the new interesting techniques being proposed. And I'm sensing from chatting with new developers and entrepreneurs looking to better understand the space that they're struggling with the same problems. And Jason, you know already we love your interview style. So we thought who better to partner with, right? Our goal is for 500 Blockcrunch series to be a carefully curated, cut-to-the-chase source of essential topics and latest developments in the blockchain space. I believe that as understanding increases, so will the community and adoption. And adoption is really key, as at the end of the day, there is no disruption if there's no adoption, right?
Well, first of all, thank you very much for the endorsement, Bonnie. And second of all, I totally agree that if no one uses cryptocurrencies, then we're not going to disrupt anything. And a huge piece of that really comes down to the scalability limitations that blockchain has. So that provides us a pretty good segue to jump into what we want to talk about today, which is scalability. So when I talk to people about scalability in blockchains, and I ask them what is the actual scalability challenge, what does that actually mean? They often offer explanations of varying complexity. For instance, some people will say that blockchains have a scalability problem because when you look at things like PayPal, which can process up to 193 transactions per second, and you look at something like Visa, which can process up to 1,600 transactions per second, it really, really dwarfs what the Bitcoin blockchain or the Ethereum blockchain can do, which is 7 and 20 transactions per second respectively. And people who are more well-versed in crypto might bring up block confirmation time as well, saying how for me as a user, for instance, for me as a user of Bitcoin, it can take up to an hour or the time it takes for 6 blocks to be mined before I can confidently say that, okay, my Bitcoin transaction is valid. And finally, people who have maybe development experience or who are deeper into the crypto space would often bring up the scalability trilemma. And one such person was Elaine Reddick, a core developer in Ethereum that I had on the show before. And what this trilemma refers to is when developers try to build any type of scalability solution on the blockchain, they often have to choose between security, decentralization, and scalability. And it's very hard for them to achieve all three perfectly at the same time. And Bonnie, I know as an investor, you've had to look at this trilemma a lot, especially as teams come to pitch you for new scalability solutions that they're building. So, can you explain where this trilemma comes from, as well as how we can navigate it?
Sure, let's first take a look at why we are facing this trilemma of security, scalability, and decentralization. Take a current payment system. I would describe it as secure and scalable, but centralized and expensive to use, right? 1 to 3% fee for credit cards, anywhere, 3 to 10% sometimes for overseas transfers. In recent years, we associate this high transaction cost to the centralization of the system, namely the handful of banks and financial institutions running the network and having control and thus pricing power. So many started asking the question, what if we have a decentralized system? Would we all benefit from lower fees and opportunity to even earn some of these fees? And then along came the Bitcoin experiment. Why it got so many people excited in the beginning is that it is the first successful experiment in production of an open, decentralized payment network that is also inherently secure against attacks, hence trusted. It is important to emphasize the word open. What it means is everyone can enter and exit the network as a participant at any time. And this is a crucial breakthrough, at least in my opinion, the Bitcoin network achieved. Because before Bitcoin, it has always been possible to create secured, decentralized networks with a closed set of participants. That is why many of us argue that private blockchains, which is essentially that secure, central, decentralized, closed network, are not true blockchains and should just be called distributed ledger technology. Now, back to the real blockchain. This new permissionless breakthrough is made possible via the new consensus protocol developed for the Bitcoin network, which we now often call it Nakamoto consensus. A side note though, sometimes people refer to proof of work as consensus protocol. That's not entirely correct. Nakamoto consensus, the protocol itself, consists of the proof of work mechanism, which decides who gets to create a block, plus a set of rules dictating how confirmation of a block is reached by all the participants. So, in essence, the consensus protocol is more overarching, where the proof of work mechanism is just a component of this consensus protocol. For Bitcoin, since the key goal in the start was to achieve an open, decentralized, secure network, the original design has placed a limit on how often blocks, which are essentially containers that hold transactions, can be created and how big each of these blocks can be. This essentially limits the number of transactions that can be processed per second on the network and how long it takes before a transaction is considered confirmed. Why? Because under the Nakamoto consensus protocol, the more decentralized and the more participants the network has, the more secure it would get, one can argue. So, how do you drive more participants in the beginning? You make sure anyone with a decent desktop computer and GPU card is able to join the network. You do that by limiting the processing and storage power required to handle the number of transactions that is being pushed through the network at any given point in time. So, in short, from the get go, there was conscious trade off on scalability to achieve the open, decentralized, secure requirement we wanted for the network.
Now, with that in mind, could you talk about what do you think are the key components of the scalability challenge in blockchain today?
There are essentially four key components: throughput, latency, storage, and transaction fees. Number one component is throughput, which is essentially the amount of data that can pass through a network at any given point in time. Think of a highway, right? Throughput is like controlled by how many lanes you have. All things equal, an 8-lane highway has a higher throughput than a 2-lane one. Number two component is latency. Latency refers to the delays that typically incurred in the propagation and processing of network data. And back to a highway analogy, I like to think of latency as controlled by how fast your car is and the number of toll booths there are along the highway. The third component of scalability is data storage. It is often less discussed, but just as important because one of the characteristics of the blockchain is that every node keeps a copy of the entire blockchain. Imagine if the latency and throughput problem is solved today. And let's say that led us to mass adoption of the blockchain of all kinds of business applications. Many nodes would not be able to handle the size increase of the chain, which can then lead to very rapid centralization of the network as these nodes drop out. In a highway example, imagine if the end of the highway is Disneyland, and you get into trouble pretty quickly if the parking lot at Disneyland cannot hold all the arriving cars. The fourth and last component of scalability is transaction fees. At the current stage, if you look at both Bitcoin and Ethereum, it is simply too expensive for any applications to have to pay for every single transaction at the current price if the application plans to have mass adoption. This is like if you have massive toll fees on the highway. No one can afford to use it, even if you have 8 lanes and super fast cars.
A lot of people, when they talk about solutions being built in scalability in blockchains, they categorize them into two camps. One being on chain solutions, which change some variables of the underlying blockchain to make it more scalable. The other being off chain solutions, or in other words, solutions that build on top of the blockchain. And as an investor who's looked at solutions that are built across all layers of the technological stack, how would you categorize the different scaling solutions out there today?
Is given the four components that impact scalability throughput, latency, storage, and transaction fees. What are the different logical approach to solving this problem, right? What are the different angles you can attack the problem from? So here are the four I find helpful in categorizing different proposed solutions. The first one is the simplest. Can we require each network participant to process faster? Second approach is how about divide and conquering, similar to batch processing? Can we make it that not every node needs to process every single transaction? The third approach is hey, can we do things smarter? Can we find better solutions to reach consensus, preserve security, and level of decentralization? Fourth approach is division of labor. Hey, maybe the best solution is not to dump every single transaction onto the blockchain. And if so, how will we go about deciding what transactions should be on the chain and how work should be divided between blockchain and other platforms? This logical framework of four angles help me in that every scalability project you come across is going to take one or more of these approaches in developing that solution. For me, this is easier than categorizing them in technical terms, as I find projects these days sometimes get very creative in coming up with new technical terms all the time.
So, what you're essentially describing are basically changes to different layers of the blockchain technological stack. And just so we can illustrate this idea clearer, let's start by diving into each of these layers one by one, starting with layer one, which is the blockchain itself. And under layer one, I like to think of there being two types of solutions, right? There's naive solutions and complex solutions, to borrow terms from my previous interviewee, Lane Reddick. So let's focus on so-called naive solutions first. These are called naive solutions because they are relatively easy, quick fixes. So these are things like SegWit, which essentially change the amount of information in a single transaction so that it becomes easier to process, and things like increasing block size, which essentially increases the size of a block on the blockchain to allow for more transactions to be processed. And these are simplistic explanations, but they essentially give you an idea of how these naive solutions are just changes to variables on the blockchain itself. And perhaps the most famous or infamous, depending on how you see it, example of such a naive solution is the increase in the block size of the Bitcoin blockchain, which resulted in a hard fork and the creation of Bitcoin Cash. So, can you talk a little bit about these so called naive solutions?
Yes, so in a sense, what you refer to as naive solutions, SegWit or Bitcoin Cash, are basically solutions that take the simple logical approach of, hey, let's try to make every participant on the network process faster. That will increase scalability, right? However, SegWit, which was implemented about a year ago, I think, I thought that was actually a pretty smart, naive solution, as by moving around the data inside each transaction and modifying how transaction ID is derived, it is able to potentially double the amount of transactions that can fit into each block as more and more participants upgrade to SegWit. I believe at present about 40% of the network have upgraded to SegWit. As for Bitcoin Cash, just like you mentioned, it's split off from Bitcoin network in order to increase the block size from 1 megabyte to 8 megabyte. And in blockchain terminology, we often refer to that as a hot fork.
And before we move on to more complex layer 1 solutions, I actually like to talk briefly about layer 0 solutions, which not a lot of projects are working on. And what layer 0 is one layer under layer 1, one layer under the blockchain layer. And this is the networking relayer level. And I've really only come across one project that's working on this. And that project's called Blockcrunch, and they're funded by folks like One Confirmation and Naval Ravikant, very notable investors in this space. And they're focusing essentially on the network propagation of blockchains. And in other words, they are worried that if block sizes increase, it will then take longer for information to spread through a blockchain network, right? And as block propagation time increases, they are worried that new blocks will be mined before previous blocks are fully confirmed, causing countless forks in the future. And this, of course, splits the community, causes a lot of problems in the future. So they are working on a relay network that helps propagate block more quickly, and they're pitching themselves as a universal solution to any blockchain out there. So I'm pretty excited to keep an eye on them. But moving promptly on to more complex layer 1 solutions, which include some fundamental alterations to the blockchains instead of changing variables in the blockchain like block size and block time, which is what naive solutions are. And these complex layer 1 solutions include things like sharding or new consensus protocols, and instead of changing variables in transactions or blocks, they seek to change the way these transactions are validated or processed across a blockchain network, and are often more complex than so-called naive solutions. And Bonnie, I know you've kept an eye on a lot of these more complex layer 1 solutions, so can you give us a breakdown of the types of projects you're seeing under this category?
When I look at Blockcrunch, what you just referred to as layer 0 and all the other layer 1 solutions, they essentially take either one of these two logical approaches to solving the scalability problem. Either divide and conquer, do some sort of batch processing, or find smarter ways to do things. So modifications on consensus protocols, propagation mechanisms, or brand new consensus protocols. Under divide and conquer, we have sharding solutions. It was first discussed as part of Ethereum's long-term solutions to the storage component of scalability. What is sharding? Sharding in the traditional database sense is a fairly mature technology. It's a separation basically of large databases into smaller and faster and more easily managed parts. Companies like Google, Facebook all have their own sharding technology. In the blockchain world, there are two types of sharding you can do: transaction sharding and state sharding. Transaction sharding means splitting up new transactions, and a given set of nodes called shards will only process a portion of these transactions. New transactions are actually not automatically propagated throughout the entire network, but only within that responsible shard. As for state sharding, remember how on a blockchain every node holds a copy of the entire state of the blockchain? In state sharding, we will split up the entire transaction history amongst several nodes so that not every node has to store and process the entire state of the blockchain. This helps solve the long-run storage issues of the chain getting too big. If you're interested in diving deeper into sharding, a few projects I follow in this space include Zeliker, which is mainly transaction sharding, currently in testnet and planning to be on mainnet early 2019. Ethereum, of course, which plans to tackle state sharding, but it will come only after Casper, which transitions Ethereum to proof of stake, is implemented. So the timeline can be a little bit longer. Perhaps we're talking about, in the time frame of 2020. And a third project is QuarkChain, QUARKChain, which aims to tackle both state and transaction sharding and is currently in testnet. But sharding also comes with its own challenges, mainly security trade-off. This is because to achieve the consensus between shards, there's a need for constant interconnectivity and communication between the shards, which obviously can have a negative impact on scalability, but is a necessary evil to prevent malicious attacks because a single shard only has a fraction of the overall hash power of the full network. Aside from sharding, which tries to tackle scalability from a divide and conquer perspective, what about solutions that look to solve scalability by finding smarter ways to do things? These are mainly a myriad of new consensus protocols, replacements of the proof of work mechanism, as well as new ways to propagate transactions like block route. For the purpose of this episode, I will not go into detail on each one, but instead highlight one or two things about each that I find most interesting. First category is directed acyclic graphs, DAG. If you envision blockchain as a linear chain, then for DAG, think about graphs of trees and subtrees that flow in one direction. Projects that are using DAG you should keep an eye on include IOTA, of course, the earliest implementation, but also sometimes, as you read into, you'll find that it's quite debatable at times whether it is truly a full DAG protocol. DAG Labs, Israeli company team, which has released several papers on a series of different protocols using the DAG approach, from Ghost in 2013 to Spectre to most recently Phantom. Hedera Hashgraph, it is now an open DAG project based on a proprietary protocol. So what it means and interesting is that if you ever try to fork it, you might run the danger of getting sued by the team. Outside of DAG, other projects include Avalanche. It's still a blockchain, but has gathered a lot of attention because it describes a family of leaderless and metastable protocols that can still achieve consensus on an open network without using proof of work mechanism. Solana, another project that I really like, it introduces a new proof of history and proof of replication mechanism to achieve transactions in the range of 710K while keeping latency still to a sub-second level. Algorand, think of that as proof of stake without staking the token. What is interesting is it proposes an incentiveless consensus that hinges on the key concept called verifiable random function. The Algorand protocol is co-authored by an MIT professor, Silvio Macaulay, who's also a Turing Award-winning cryptographer. Then there's Thunderella, essentially splits the highway into fast lane and slow lane. And under normal circumstances, if over two-thirds of the network nodes are honest, all the transactions will be pushed through the fast lane. And only on the event of error that the network will fall back on so-called the slow lane. Last but not least, Stellar, one of my longtime favorites, been running on mainnet for a few years, and it manages to confirm transactions in seconds using federated Byzantine agreement.
I'll definitely include these projects in the show notes. And I think it's surprising to a lot of people to know that a lot of these newer, so-called newer consensus protocols and ideas have actually been floating around for quite a while, especially in the academia circle since the 80s and 90s. But this is really the first time we've seen so many ideas and projects being practically implemented. And personally, I'm pretty conservative when it comes to layer 1 solutions, but I'm pretty interested in seeing whether these newfangled blockchains and consensus protocols could stack up against relatively quote-unquote tried and true blockchains like the Bitcoin blockchain. And I'm pretty sure we'll see a lot of exciting projects emerging from layer 1. But just as a matter of personal curiosity, I'm actually more interested in layer 2 solutions. And these are solutions that are almost built as extensions of the blockchain. These are solutions that are building on top of the blockchain instead of trying to change something about the blockchain itself. But they still rely on the underlying blockchain for security and for settlement. So what this means is that these layer 2 solutions essentially retain the best aspects of blockchains and execute scalability without compromising too much. And one of the most exciting layer 2 solutions is state channels, which are essentially just bar tabs for the blockchain. What this means is I really only have to write a transaction onto the blockchain twice, when I open the tab and when I close the tab. And any of the transactions that are being conducted through this state channel are basically instantaneous because we don't have to wait for confirmation on the blockchain and we don't have to pay transaction fees. And this is super important because even with other scalability methods like sharding or any of the methods that we discussed just now, applications that rely on a large number of individual operations such as streaming payments or IoT devices that send a lot of packets of information to each other, they're still not reducing transaction fees to a point where they become infinitely scalable. And as you've mentioned before, transaction fees is a key piece of the scalability puzzle as well. So can you talk a bit about how these layer 2 solutions such as state channels could affect fees, as well as how they could affect scalability, and what are some of the most exciting projects you've seen at this layer of the blockchain stack?
Referring back to the four logical approaches, the last one is division of labor. And this is where I see all of the so called layer 2 solutions they fall under. As what teams here are exploring is, can we solve scalability by keeping only critical components on the chain while moving everything else into a separate stack or layer? State channels is one of the solutions proposed, where direct channels are being established between two parties where transactions take place directly. Only upon final settlement, once the channels are actually closed, is the final settlement being processed by the underlying blockchain. While this will certainly alleviate the work burden on the blockchain, state channel projects do still need to address the fact that at the end of the day, someone or organization will need to host and operate this second layer, which can, in its own terms, introduce both additional fees and also a potential additional point of failure in terms of mismanagement, hacking, or corruption. Several projects making headway in this space include Lightning Network. It's a payment-specific state channels architecture that currently works on top of Bitcoin and Litecoin network, while other main blockchains such as Ethereum and Neo also have their own implementation of payment state channel projects, namely Raiden Network and Trinity, respectively. Lightning is the first one to be live in production and by far the most referenced. Actually, a lot of other major blockchain projects such as Zcash, Ripple, Stellar, all earlier this year have indicated that they will test the Lightning networks on their blockchain. In addition to payment state channels, we also have what we call generalized state channels. The concept was first introduced in the Ethereum community to extend state channels to other activities outside of payments. One of the goals of generalized state channels is to enable developers to incorporate blockchain into use cases and applications without needing to become necessarily experts in blockchain specific areas such as smart contracts or Solidity. Several projects to watch in this space include Counterfactual, which is being worked on by the L4 team and essentially is Ethereum's generalized state channel solution. Recently, they have announced a collaboration with Stellar Network, another generalized state channel project founded by a team of four PhDs from Princeton, MIT, UIUC, and Berkeley. A third one, which I personally would love to learn more about, is Peru Network, which is a virtual state channel, meaning it would not have the problem of needing a third party to run and thus reducing transaction fees.
And on top of these solutions, there's also something called off-chain computation, which I don't think as many people are aware of. And one lesser-known project in this is called TrueBit, which I think we should definitely mention because they're taking a very interesting approach to tackling the scalability issue by essentially building a layer 2 on top of the blockchain that does the heavy lifting when it comes to computation. So can you talk a bit about that as well?
In the most simple form, a project like TrueBit is specific for blockchains such as Ethereum, which aim to be the so-called decentralized supercomputer, right? To be a supercomputer, besides being able to handle many, many transactions quickly, we also need to be powerful enough to handle very heavy computation transactions. And this is what the project TrueBit aims to do. It's a little like when we have GPUs to do what even a super fast CPU cannot do. In the realm of the scale of complexity of the computation a chain can handle, there are also other interesting projects who are essentially rebuilding base chains tailored to handle large amounts of complex computations. One such example is Hypernetwork out of Stanford. These are a bit like the ASICs, right? Purpose-built chains. If we believe the end vision is it will be a world of many blockchains, then all these purpose-built chains can be interconnected to general payment chains like Stellar, Bitcoin, and general computing chains like Ethereum via the future layer 2 stacks, which could be a variation of our current generalized state channel solutions. So if we summarize all the solutions we talked about just now, they're all trying to solve one or more of the four key components of scaling we mentioned: throughput, latency, data storage, transaction fees. And this last one set we talked about, the TrueBit, the hypernetworks, go a step further and look at how we can scale the complexity being handled. Doesn't that remind you sort of our last few decades of computing? On one hand, we are racing to increase clock speed on the CPUs, and on the other side, developing the GPUs, TPUs, ASICs that are designed for complexity handling. And the way projects are solving the scalability challenge is really through four angles we talked about already. From number one, the naive layer solutions, right, of simply forcing all participants to work faster, to number two, divide and conquer through batch processing, such as sharding, to number three, finding smarter ways to perform consensus. And lastly, number four, division of labor, specialization. These are the layers like state channels and side chains. I hope this provides, in a way, a simple framework for assessing new scalability projects for our listeners. The list of sample projects mentioned here are really in no way exhaustive, and each of them easily deserves an episode of their own. You know, these days, every project tends to have a 40-page white paper, and oftentimes they're not stuffed with really, sometimes I find a lot of unnecessary mathematical equations and jargons. But what's actually more important for an investor, and I would believe also for developers looking to contribute to the space, is where actually these projects are in terms of development at this point in time. As an investor, I find updates on these progresses and new challenges, obstacles they face quite crucial. So that's the kind of information we set out to dive deeper into together with you in this 500 Blockcrunch scalability series.
Yeah, absolutely. And I'm really excited to bring more to our listeners as well. So thanks for coming on the show, Bonnie. And hopefully for our listeners, in the past 30 minutes, we've given you a summary of some of the major questions being asked in the scalability challenge that's facing blockchains today, as well as the major types of solutions that amazing teams around the world are building. Of course, this wasn't a comprehensive summary because there's just too much to cover. That's why in the coming episodes, I'll be talking to founders of some scalability projects to learn more about the nitty-gritty of the implementations of solutions that Bonnie and I discussed in this episode. So if you'd like to continue using this free resource and continue diving deeper with us on the topic of scalability, then definitely stay tuned and subscribe to this podcast. And you can even give us a 5-star rating if you think we deserved it. And you can also follow me on Twitter at Mr. Jason Choi, where I consistently share some of the resources that I use when researching for this podcast as well. And next up, I'll be talking to the founders of Solana and Stellar, both of which are incredibly exciting projects. The episode with Solana in particular really made me rethink what blockchains are. And with that being said, this has been the first episode of 500 Blockcrunch. I've been your host, Jason Choi, and thank you for listening.